Okay, blah blahs, here we go. Now, Jensen, what do you think? Why? What's interesting about that is, now, it doesn't tell us anything about the angles. Technically, the only thing that we have learned to show that triangles can be similar is if all the angles are congruent and if all the sides are proportional. Now, it doesn't tell us the angles. We're not allowed to assume that. So technically, right off the bat, it's no. But given the sides, we're not looking to see if they're congruent. We're looking to see if they are proportional. Brandon.
J, H, and C, and E are different scale factors. So.
Ooh, nice vocab. That's exactly right. Yesterday, the one with the rectangles, almost every single person in here messed that one up, and I had to explain it. Because they're like 32 and 48 or something like that. Those don't go together. These triangles are turned around from each other. You have to match the biggest sides and the smallest sides. What is the biggest side of this triangle?
A, C, and J.
That's very good. And you need to put those in a ratio. What does that reduce to? 1. What's the smallest sides on these two? What does that reduce to? 1. Anything divided by itself is 1. So far, our scale factor is 1 to 1. Then we go to the third side. Is that the same as the other two? No. If they do not reduce the same way, then the scale factor is not universal, and they are not... Darn, you can't see anything that I'm doing right now. They are not similar. They're not similar unless your scale factor is the same for all three. This one was 1, this one was 1, this one was not 1. Match the biggest sides, match the smallest sides. Don't just think you can look at a shape and left, up, right. Doesn't always work like that. As that example yesterday should have shown you. One with the rectangle this way, the other with the rectangle this way. I'll turn it down. Today, some of you guys are going to love today, some of you guys are going to hate today. If you enjoyed, which I'm guessing none of you... Oh, I need to pass out paper. I'll do it later. If you happen to enjoy the section where we showed the triangles were congruent, then you'll probably like today. Although, when I pass out these papers, you'll probably find that not many of you did, because not a single person in here got higher than a 7 out of 10 on the main worksheet where I passed out, where you had to say if they're congruent or not. Today we're going to be doing the same thing, except we're going to be showing that they are similar. Drew, you got to stay awake, buddy. We're going to be showing that they are similar. We're going to knock out 2 sections in one day. Now I know at least 2 of those should look familiar. Went down on top. 6-4 and 6-5. We're going to prove triangles are similar. Now, just like when we were showing they're congruent, you could do it using side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Well, there's only 3 for similar, so that's even easier. And there they are. The first one, angle, angle, similarity. Angle, angle, similarity. If you know that 2 triangles have 2 common angles that are the exact same, that right there is enough to show that the triangles are similar. Why do you think it's only necessary to know 2 of the angles? Why not all 3? Who can tell me? Why do you think it's only necessary to know 2 of the angles? Why isn't it necessary that we know all 3? No. Let me give you an example. Let's say we knew that these were both 100. Well, let me change colors. second, Donovan. Let's say we knew both of these were 100, and we knew both of these were 40. 40 is a bad example. 50. Donovan, why is it only necessary to know two of the angles? That's right. What do all angles in a triangle add up to? Very good. I'm probably going to call on you for that question all year, just for whatever reason. All triangles add to 180. So if you have two of them, just like Donovan said, you can then subtract and find out the third one. And if two of them add to the same thing, don't their third ones have to be the same? Yes. This will have to be 30, and that will have to be 30. That's why it's not necessary to know all three angles. That's important to you, because in a minute, I'm going to be showing you random triangles. In fact, most of your entire assignment today, I'm just going to show you triangles and say, hey, can you tell me those are similar? You only need to show that two angles are congruent. Just two. To show the triangles are similar with one another. Oh, it's 50. Oh, that's accidentally a dot. It's 50. My apologies. Questions on that one? Now, the next one's going to look familiar, but it's different than the original that we did like this. Because the original said all three sides had to be congruent. Not the case anymore. Now they just have to be proportional, which means they have the same scale factor, which is exactly what Brandon did in the DOM. He set up his scale factor, saw that one was different, boom, not similar. This is exactly what Brandon used in the DOM without even knowing it, which is impressive. Logic. So much of geometry is just logic. So many of you look at a problem and freak out because you don't actually take the time to think, what's this asking me? If you actually ask yourself that, a lot of the time, the answer is kind of obvious. Yes. If all three sides are proportional, then your triangles are similar. I would do a dance if I would think it would help. All three sides are proportional, then the triangles are similar. Quick little example. Thank you. Quick little example. 2, 4, 6, 1, 2, 3. Are all three sides, do all three sides have the same scale factor? Then they're similar by side. 2 to 1, 2 to 1, 2 to 1. Bang. That's all you have to show. Notice, they're not the same. They're just proportional, which is the same thing as saying they have the same scale factor. Anybody need me to leave this up there? Last but not least, side angle side. If you don't know two angles, and you don't know all three sides, maybe you know two sides and the angle between them. That is the important fact here. The angle between those sides. So, for instance, if we were going to try to use side angle side on this one, you would need to know these two sides, because they're around the angle, and these two sides. And here's what an example of that would look like. 6, 4, 3, 2. Does 6 over 3 equal 4 over 2? Yes. Those two sides are proportional. Notice I don't need to show all three. You only need to show two if you know the angle between them. Now, if you had known that either of these two angles and those sides, could you have done this? No. It has to be the angle between the sides. Now, Coach K has a really good method for doing this. What he does, every time he sees his triangles, he immediately marks what he knows. He's like, okay, I know this side, this angle, and this side. And then a lot of times, the answer's staring him in the face. What he's supposed to use? Side, angle, side. He showed me that. I think it's a good idea. So if you need to do that, then do it. Every piece that you know, mark it. And then maybe whatever you're supposed to use will kind of jump off the page at you. Questions about what this one is asking? That's all the notes. That's all of them. In like 14 minutes, we've covered all the notes. All we have to do now are examples, examples, examples because it's not always going to be this easy. Sometimes you're going to have to notice the vertical angles theorem. Sometimes you're going to have to notice the reflexive property. Sometimes you're going to have to notice alternate interior angles, etc. Corresponding angles. All the stuff from the previous part of the year. But it's all going to end up with this. In fact, the whole next slide is to remind you. On your homework today, I believe 7 of the 10 questions are they similar or are they not? And regardless of whatever else you have to use, if they are similar, you have to say one of these. Must. If they are similar, you have to end with one of these things that we just wrote down. If you cannot show any of those 3, then they're not similar. Not. Any questions about what our game plan is about to be? Okay. Number 1. Determine if in the 2 triangles we have enough to say, now don't you dare just blurt out an answer before you think about this and think about what you know about these triangles. Do we have enough to show they're similar, and how do we know? Chris. Good observation. However, I guarantee you most people in here right now are looking at like 38 the same as 52. I can see they ain't the same. However, Elon, what do all triangles add up to with their angles? 180. Therefore, how can we find that angle? Add them up and subtract. All year we'll be adding and subtracting. 90 plus 38. We're going to subtract that from 180. So who can punch that in the calculator for me? 180 minus 90 minus 38. Yes. 52? Hot diggity dang. Well, in that case, Tripp was right. Angle, angle. Now today, I'm not going to make you give a validation for that, but if you're going to use angle, angle on a problem where it shows different ones, I at least want you to write in the triangle that this is 52 and that's 38. That way I can at least see where you're getting these corresponding angles. If you give me angle, angle, and don't at least mark in that the angles that you've recognized that they're the same, then I'm going to mark it wrong. Now, you could have assumed angle, you could have assumed that if you were going to be able to do it, it was going to have to be angle, angle, how? How could you have assumed that if you were going to be able to do it, you were going to have to use angle, angle? That's all they gave you. They didn't give you any sides. They don't give you sides, that makes it easy. And if they don't give you any angles, what do you have to use then? Side, side, side. If they ever give you both, that's a screaming indicator that you're probably going to have to use side, angle, side. Questions about why this was yes and how we came to that conclusion. What about this one? Oh, wait, is that the same exact problem? Just kidding, not that one. Okay, what about A? This one is these 2 triangles. Now, pause for a second. Is that the same as this? No. Those have 1 dash. These have 2 dashes. Well, do we need them to be the same? No, that's not the point. So, again, do we have enough? What do you think we're going to use, Blake? Side, angle, side. Now, some people are like, whoa, 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 whoa. I see the angle, but how can you show the sides have the same scale factor, right? However, it doesn't matter. Because, watch. Pick any number in the entire world for this side. 922 it is. This is longer, so let's make this 1,000,000,007. Nope, wait, 7. Well, that's only 1,000,007. But whatever, we're going to save time. 1,000,007. Okay? Who cares? What's the scale factor from this to this? Non-reduced. You don't have to reduce it. 922 to 1,000,007, right? It doesn't matter what the numbers are. Can we show that these 2 sides have the same scale factor? Yes, because they're the bloody same in both cases. If they're the same, then it doesn't matter. Whatever they are, they're going to be the same. So, good observation, and yes, that one, all you would need to put is side, angle, side. We have not yet done one where you have to do multiple things until part B. Epoxy. Now, first off, raise your hand if you'd like me to point out the fact that there are two triangles in this picture. There's this one, and then there's the whole thing. Now, earlier this year, I gave a hint about what we're going to have to use at times like these. Oh man, good memory. Which side and or angle do we use RPOC for? No. Because PQ has nothing to do with the big triangle. It's just kind of going through the middle. Very good. Angle N. Angle N is in both the small triangle and the big triangle. So that's one angle we have shown are the same. Now, before we go any further, if we're going to show these are similar, what are we going to have to use? Do we know any of the sides? So what are we going to have to use? Angle, angle. We're going to have to use that. And we've shown one. We only need to find one more. We've shown that angle N is congruent to angle N by RPOC. And this is the kind of thing you're going to have to list today. The reflexive property of congruence. Reflexive property states that angle N is the same for both triangles. That one's down. What's the other huge screaming at us hint in this picture? You don't have to tell me what it means, just what is the hint? Yes? That's what, was it you that said it, Donovan? That's what Donovan said, except, technically yes, except, and that is a side of that triangle, but it's not a side of this triangle, it's just a line going through it. See why that's not ultra helpful. But you were correct in that observation, yes. Parallel lines is the other hint. First chapter of the year, we talked about parallel lines till we were purple in the face. We were talking about alternate interior angles, the consecutive angles, the corresponding angles. Which one appears in this shape? And when in doubt, draw it for yourself. Redraw it without all the white noise stuff. What do we have? We have, very good, I'm going to come back to you. We have two parallel lines, right? And I'm going to go ahead and draw this side, right? Now, this is what we're looking at if I were to keep drawing the lines. Now, this angle here would be this one, and this angle here would be this one. What kind of angles are those, Justin? They are corresponding. They are corresponding angles. If your lines are parallel, and you have corresponding angles, what do we know about those angles, Donovan? Donovan, answer my question. If you have parallel lines and you have corresponding angles, what do we know about them? They are the same. By what? Who can tell me how we know that? Anybody? Give you a hint. It has corresponding angles and one word after it.
Oh,
Postulate. The corresponding angles postulate states. Actually, you could use it twice. You could use it for both of these angles. But we only need two of them, so why reinvent the wheel? We know that those two are the same. Is that enough right there? Yes, that's two. We have one angle for both triangles. We have a second angle for both triangles. Bang, angle, angle. Bang. Actually, you technically didn't even need RPOC. You could have just done corresponding angles postulate twice and then had angle, angle right there. There's multiple ways to solve these. So, here's the kind of thing I need for your answers today. This is what everyone messed up on at least 30% of the time last time we did these for congruence. I need these pieces listed. RPOC, corresponding angles postulate, angle, angle similarity. Every one of them is either going to have to end with one of these, one of those three, or just a no. You can't show them. And there are some that you can't show. Questions? I don't know how else to say this without like shaking my hands. If they show you parallel lines, I guarantee you there's going to be some angle in there that's congruent. That's the only reason they would show you parallel lines, for corresponding angles, for alternate interior angles. Somewhere in that picture, along those two parallel lines, are angles that are congruent. That's the only reason they would give them to you. So if you see arrows and you don't make some kind of angle observation, shame on you. That's what they're telling you. All right, let's look at a few more examples. What about these? What about this one? Ooh, jumped right on it. Oh, you too. Vertical. There are vertical right here. Is that enough? Yes, it is. Rachel, how would I finish this one up? Very good. Vertical angles theorem, angle, angle. Vertical angles theorem, angle, angle. Very good. What about Elijah? What about number 2 here? Elijah, what about number 2? Don't you shrug at me. Elon, what do all angles in a triangle add up to? Elijah, can you find out what those other angles equal? Okay, how? Explain it to me and I'll do the work. That's right. Plus our phantom angle, we'll call it x, right? 180 equals 90 plus 19, I got those backwards, plus x. Solve for x and you'll find that this angle is 71. So I come back to you, Elijah. Do we know if these triangles are congruent or similar or not? They are. Look, they have one angle in common. They have a second angle in common. That's all we need to say that they are congruent or similar using what? Alcoholics Anonymous use the same acronym. There you go. Angle, angle. Questions?
Good morning, Junior County High School. If I could have everyone's attention for just a moment, we are about ready for the.
Julie, I believe in you.
Oh, that's so sweet. Okay.
I know.
That's sweet as well, I guess. All right, here we go. Num 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 num. I'm gonna pick on Jensen because he said he's gonna answer my questions today. Hey Jensen, what do I know about this picture? Check. What else do I know?
2 arrows pointing up.
What do those mean? Oh, but that's actually correct. But can you tell me what they mean?
The arrows.
Yes, the arrows.
What it be?
Hey, that's the right observation. What is it?
The word. The word for it.
Yes, that is what I'm going for.
Parallel.
Yes! Yes. Parallel. And what did I say? If they give you parallel lines, what is it trying to get you to notice? Some kind of angle, right? So, now I didn't label these. Let me label them real quick. Very good, sir. I'm going to be coming back to you in just a second. No. He has to know it. You back off. Back off! Okay. I'm watching you. Now, who can tell me which angles in this picture can I show are congruent using my parallel line? Play. All 4 of them? You can only show 2 at a time. Yes, ma'am. Aw, I got pretty good. Sage. Yeah. There yet, but yes, we can. How can I send you? Yes, we can use vertical angles. Absolutely. That would give you 1 right here. However, you need a second. Who can tell me which angles we can show and how? Yes, sir. Yes, sir.
Okay, the vertical angle.
Already used that. There is no more vertical angles. For vertical angles, there has to be an intersection on opposite sides like that.
There has to be a both sides. But that thing keeps the parallel lines going up and the other line.
Here, that's just because I failed to draw it correctly. Who can tell me what kind of now? 1 second, even if you know it. Try to remember. In fact, it would be helpful to you to put this in your notes. To put this into your notes right now. If they give you parallel lines, I'm going to underline it bananas to make sure you know it's extra important. If they give you parallel lines, there's usually only, for this kind of thing, there's really only 2 types of those angles that we learned about. We learned about alternate exterior, consecutive, blah, blah, blah. But there's only 2 times that you will normally ever need to know when they give you. One of them's corresponding, which has R's in it. Corresponding angles. And now you would use that by using corresponding angles postulate. Or the only other one you will pretty much ever need is alternate interior. Alternate interior. That's what we're using right now. Now, let me go back to the other time we used this. Now, do you see how the 2 triangles are kind of inside one another? I'm going to give you another ginormo hint here. When the 2 triangles are right inside each other, and you see how the angles are kind of layered, that's when you're going to use corresponding. I don't know how you're going to mark that in your notes. If you want to draw yourself a diagram, be like, hey, corresponding will look like this. But when the sides that go through the parallel, see how these are the sides going through the parallel line? When those cross like that, they'll almost always, 98% of the time, be wanting you to notice alternate interior angles. Okay, Donovan. If we're going to use alternate interior, which angles are congruent? Very good. A and C are alternate interior. And actually, you could have used alternate interior twice. Not that you would need to now. But what's the other 2 angles you could show are congruent? B and D. B and D. So, here's what you should have written for your answer. Vertical angles theorem. Alternate interior angles theorem. 1 second. And then angle. Yes, ma'am. It could, but just like we were talking about earlier, once you know 2, the third one's kind of superfluous. Really, only 2 is all you need to know. Because if you know 2, they have to subtract 1 equals 3. So you're absolutely right. You do know all 3, but you only have to tell me 2 of them. Questions. That's going to be what you have to do. Notice that kind of thing. Only other thing you have to do today is this, and these are the much easier problems. Oh, real quick, I forgot about this one. Here are 3 triangles. We have to find any 2 that are similar. If we're going to show it, what are we going to have to use? Rachel, what are we going to have to use if we're going to show those are similar? Very good. But which of the 3 that we learned today, like what's the name of the one we're going to have to use? Yeah, we don't know any bloody angles. You're going to have to use side, side, side. And actually, these are the 2 from your DOM. Those are the 2 from your DOM, which you've already shown are not similar. What about these 2? Let's set those 2 up. Yes, me. Can you see from back there? Do you have your glasses today? No? Okay. Starla, what's the smallest side on this one? Smallest side. Just give me the number. There you go. What's the smallest side on this one? 6. We're looking to see if these 2 are similar. Starla, what's the biggest side on this one? Very good. What's the biggest side on this one? What's the middle side on this one? $12. And what's the middle side on this one? It's a 9. Now, please notice, we didn't try to just eyeball it. We looked with the biggest, smallest, and medium. Now, Amber, Elon, Elijah, Drew, Brandon, heads up. I'm going to start having write-ups for this stuff. The sleeping's getting out of control. Good. Do these all have the same scale factor? What does 8 over 6 reduce to? You can use your calculator. 4 over 3. What does 16 over 12 reduce to? 4 over 3. What does 12 over 9 reduce to? Are they similar? Yes, by side, side, side. That's what you have to do if you're going to use side, side, side. Last one. We have it. Oh, I'm not doing that one yet. Okay, here we go. If they are similar, now Lotus, it tells us that they're similar. You don't have to tell me side, side, side or anything like that. What you have to do is know if they're similar, you have to put the pieces together, just like we did yesterday. So what's the first x we have to solve for? BC? BC corresponds to which side on the other triangle, Rebecca? BC corresponds with which piece on the other triangle? Very good. It's in the similarity statement. So BC is x minus 1. What is EF? And you can solve for x. What's the other one we have to find? DF? DF corresponds to which two letters in the other triangle? AC. So 3 times x plus 1 equals 8. And you have to solve for x there too. I'll help you with that one. That'd be 3x plus 3 equals 8. Subtract the 3. You're going to get a fraction, but that's okay. Divide both sides by 3, and x equals 5/3. There are 3 like that today, but we're only going to do one example of those because all you have to do is identify the congruent pieces and set them equal. I'm exhausted. All right, there is no book work for this. I just